Hello everyone. Today we're going to introduce you how to find an equivalent orifice to represent a simple hydraulic network. In this lesson, our learning objectives are to understand the functions of components in a hydraulic system. Then we will explain the calculation of an equivalent orifice, which can represent a hydraulic network consisting of orifices with different diameters. Let's review the demo model of excavator. It is created with components from HYD library. There are three main hydraulic circuits, including boom actuation, dipper and bucket actuation, and the swing system. How to understand this hydraulic circuit in a simple way? To read or understand a hydraulic system, we usually start from the pump. A pump is a hydraulic power supplier which is used to provide enough power or requested power to actuators to move or rotate the mechanical load so that the system can reach the design objectives successfully. It will increase the system pressure in the hydraulic circuit. Besides, in the hydraulic circuit, there will be different kinds of valves to control the system pressure, flow rate, or flow direction, depending on system operating points. Valves are resistive components like orifices, which can be considered as power consumers. They will cause pressure drop in the circuit. So somehow all the different branches can be considered as orifices, and the combination of all orifice branches will form a hydraulic circuit. Now we will use a small model shown in this slide to demonstrate how to find an equivalent orifice to represent this complete hydraulic circuit. In this circuit, the pressure source is set at 10 bar, and orifice with diameter d1 is 5 mm, and d2 is 5 multiplied square root of 2, which is around 7 mm. By doing this, we can have flow rate Q1 at all orifices with diameter of d1 are 30 liter per minute, and Q2 are 80 liter per minute at orifices with diameter d2. Then you can simply get the total flow rate from pressure source. It is 3 times Q1 plus 2 times Q2, and it is 280 liter per minute in total. As second step, we will try to convert this network of orifices into one single equivalent orifice, but still have the same total flow rate. We already know the total flow rate is 280 liter per minute, so we just need to find the flow area or orifice diameter of this single equivalent orifice. The diameter of this equivalent orifice can be expressed as a function of d1 and d2. From previous topics, we already knew the flow rate calculation of an orifice. For simplicity reason, we will consider constant pressure drop, density, and flow coefficient CQ. It will make the calculation easier so that we can focus on our topic. Since now these three items are considered as constant values, then we can replace them by a simple letter capital K, and the equation becomes the total flow rate Q tot equals to K multiply the equivalent area S, or K prime multiply square of equivalent orifice diameter. Under same assumptions, the equations for Q1 and Q2 can also be defined with K prime to multiply their own diameter. Finally, we can convert the equation for total flow rate calculation into a new one. We will replace the flow rate with the expression where the function of diameter is used. Then the equivalent orifice diameter can be expressed like this. d1 is 5 and d2 is 5 multiplied square root of 2. Then we can get the value of equivalent diameter, 5 multiplied square root of 7 mm. Let's summarize what we've learned from this short lesson. A hydraulic circuit can be considered as orifices network in a simple way. Also, we practiced how to calculate an equivalent orifice of orifices network. With this, we end our lesson on equivalent orifice calculation. Thanks.